Alright, so we're talking about circles for this chapter, and we're specifically starting with tangent lines. And so a tangent line to a circle has a point of tangency, which just means it's point B, where it's just touching the circle in one spot. And then the line that connects it is the tangent line. So this is not like sine, cosine, and tangent. This is totally different. But this point that touches it in one spot is a tangent line. And we have a property that when we have a radius drawn to a point of tangency, so P is a point of tangency, it's a tangent line, then it's 90 degrees, it's perpendicular. So we're able to, from there, do a lot of things. And so the key part is whenever it's tangent, it's going to be 90 degrees. And we use that down the road here. So we have a couple of examples. We're given that BA is tangent to circle O at that point, and we want to find X, which is here. So what's missing is that this angle here is actually 90 degrees. And so it's just the triangle sum theorem. So we have the angles in a triangle are going to add to 180. So if we have 90 for point A, that means that X and 22 have to be the rest of it. So X equals 90 minus 22, or 68 degrees. The next one we have pulley belts. So this belt goes around these pulleys and around these pulleys, and we're trying to figure out some distances between the centers, given what we know about the amount that's here and here. And so our big concept is that we're going to take these lines, we're trying to figure out how they move down like that. And so if we take that line there, that distance of 15 is not drawn great, but that 15 drops here, that's 90 degrees, so we're basically just sliding this down until it just touches right there. And then the amount we moved it down was this radius, so that's 3. So what we're left with is that's 4 on that side. So we've created a right triangle, and we can figure out the missing piece, the hypotenuse, with the Pythagorean theorem. So it looks like this: 15, 4, and something, which is going to be the square root of 15 squared plus 4 squared, which gives us our value there. So if we are looking at other examples, so let's say we have circle W with a radius of 5, and point P is outside of it, so it's something like that, and we have a distance there. And we have point A such that it's tangent, and we have our values here. We're looking for the idea of, is this going to be perpendicular? Well, it works out to be that we have a 13, a 5, and a 12, but if we apply the Pythagorean theorem, 5, 13, and 12, a squared, b squared, c squared, we see pretty quickly that that's not going to work. And so it is not tangent. It can't work there. Now, if the 13 and the 12 were reversed, it would be tangent. We'd have a 90-degree angle using our converse Pythagorean theorem, but it doesn't work, so it's not tangent. All right, our next property for tangent lines deal with one point drawn to 2 points of tangency, and it works out that they are the same. They're congruent. So these two distances are going to be the same for this to work out. And we could draw a kite and show how that works, but we're going to skip the proof for it. But we're going to use that idea to talk about how we can see we have our kite here and our properties of perpendicular diagonals. We could show it with congruent triangles and then corresponding parts to show that those pieces are the same. But more often than not, we're going to have something more algebraic as we're solving these things. So what it would look like is something like this. It might look complicated, but it's really not too bad. So we've been given all these points of tangency, tangent, 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 which means these distances are the same, and we're asked to find the perimeter of this whole thing on the outside. Well, those are going to be the same, so that's 11. Those are going to be the same, because that's 7. Those are the same, so that's a 6. Those are the same, so that's an 8, and we just add them all up. So our perimeter is 2 times the sum of all those sides, or 2 times 32, or 64 feet. So not too bad.